All right, so if you see now the interval starts at 0 and goes all the way to 2 pi. So we're not telling you which quadrant you're going to be in. That's going to be up to you to figure it out. So first thing, step 1 was to isolate the trig term. So the trig term in this problem is cosine theta, or cosine. So I want to get that by itself. So just do some algebra here. We're going to add 1 to both sides. And you don't have to show all these steps, but I'm going to show it now since this is kind of weird looking. And then I'm going to divide both sides by radical 2. Okay, so then I have cosine theta is equal to 1 over radical 2. Well, we can't leave a radical in the denominator. So I'm going to multiply to rationalize. And so cosine of theta is going to give me positive radical 2 over 2. Remember, cosine is my x value. So what I'm going to do here is I'm going to graph, and I need to think about on this graph, where are my x values positive? So x values are positive as I go to the right. So I'm going to have one triangle right here where my x value, this is my x value right here, radical 2 over 2. And then I've got another one right here. This is part of that bow tie. Remember back when we were doing the bow tie ones? So I didn't use this left side because my x values would have been negative. I don't want that. Now, if my x values are radical 2 over 2, that means that my y values are also radical 2 over 2, which gives me a 45-degree reference angle, or pi over 4. So both of those reference angles, here I've got two triangles here. I'm going to get two answers for theta. One of them starts right here and it goes to there, so it's the same thing. So one of my answers, theta, is going to be pi over 4. The other one starts here and it's going to go all the way around almost a full circle, almost all the way to 2 pi. Now, since I'm dealing with pi over 4, I'm going to change that 2 pi into 8 pi over 4, so they have the same denominators. It doesn't quite make it to 8 pi over 4, so I need to subtract pi over 4. So 8 pi over 4 minus pi over 4 is going to give me 7 pi over 4. And so I get my theta, the times when cosine is going to be positive radical 2 over 2 is pi over 4 and 7 pi over 4. All right, let's try another one here. This time we have sine, but we have it twice. I don't want it twice, I just want it once. So I need to isolate that sine. So I want to get them on the same side. So I'm going to subtract 3 sine theta, and that gives me 2 sine theta minus radical 3 is equal to 0. I'm going to add that radical 3 over to the other side. Hopefully I didn't skip too many steps there for you guys. And now I'm going to divide both sides by 2. So I've got sine by itself. Sine theta is equal to radical 3 over 2. I'm going to have to start writing smaller. I'm running out of room here. All right, remember, sine is our y value, and it's positive. So that means I only want y values that are positive. So when I make the part of my bow tie, I only want it to be going up because that's where my y values would be positive. Y is positive when it goes up, so that's radical 3 over 2. And then here's another one here. That's radical 3 over 2. So now I have to figure out how big are those reference angles that are across from radical 3 over 2. What I like to do, 1/2 always matches up with 30. You can go back and look at this. So if your y value is radical 3 over 2, that you know you're going to get a 60-degree angle or pi over 3. So my reference angles are both going to be pi over 3. It does help to label these. So over here is where I have pi. Full circle is 2 pi. I don't really need the pi over 2 right now. So I've got two triangles, so I'm going to get two answers. One of my answers is just right there in the first quadrant already. So theta is equal to pi over 3. If it's in the first quadrant, it's always just going to be the same as that reference angle. The other angle is going to not quite make it to pi. Since I'm dealing with pi over 3, I'm going to change this to 3 pi So in order to get that angle in that second quadrant, I would have to do 3 pi over 3 minus pi over 3. Oh, I wrote 2 there. To give me 2 pi over 3. So my two angles are pi over 3 and 2 pi over 3. If it would have been in this quadrant, then you would have done 3 pi over 3 plus pi over 3. Just kind of give you an idea there. All right, next one, cotangent. Okay, it's kind of one of those weird ones, but we can do this. Notice that that says squared. All right, first thing I'm going to do is I'm going to try to get that cotangent by itself. All right, so first thing I'm going to do is I'm going to add the 3 over to the other side. So I've got cotangent squared theta is equal to 3. Now, think about how we get rid of something squared. We square root it. Don't forget, whenever you take the square root, you need to do plus or minus. So whenever you take the square root, you need to have a plus or minus. So what I have here now is I have cotangent theta is equal to plus or minus radical 3. Now, cotangent is one of those weird ones. It's a reciprocal of tangent. So if you want to, you could flip that over. You could change that to tangent. And then that would really be plus or minus 1 over radical 3. You could just do cotangent, leave it there if you wanted to. But so tangent I know is sine over cosine. It's y over x. Cotangent would be x over y. But so tangent is y over x. That's what I always remember. Now, if I need ordered pairs that are going to simplify, and I know that radical's at the bottom, but just leave it for now. So look back at your ordered pairs from your unit circle. Obviously, the radical 2 over 2's, if I divide those, it's not going to give me 1 over radical 3. So it's going to have to be one of these pairs. I want the top to be a 1 and the bottom to be a radical 3. Remember when we pair these up, those 2's will cancel out. So what I would do here is I would put 1/2 on top, radical 3 over 2 at the bottom, and notice those 2's cancel out. So that's going to give me my y value is 1/2 and my x value is radical 3 over 2. Now, since it's plus or minus, think about that. Plus or minus could happen in any of the quadrants. So this time we're going to get 4 answers. We're going to make that bow tie the whole bow tie. So we're going to have 4 triangles here. Whenever you're plus or minus, you're going to do this. So tangent, I need my y value to be 1/2, or it could have been negative 1/2. So as soon as you can get one of those reference angles, you don't have to do all of these. But think about what angle is across from 1/2. When y is 1/2, that's going to give you a 30-degree angle, or pi over 6. So these are all going to be 30-degree angles, or pi over 6. All of these reference angles are pi over 6. So we're going to get 4 answers here. Let's go ahead and label some of these. I'm going to change this to pi. Since it's over 6, I'm going to just go ahead right away and change it to 6 pi over 6. Over here I've got 2 pi, but I want that to have a denominator of 6, so I'm going to change that to 12 pi over 6. 12 over 6 is the same as 2 pi. All right, we're looking for 4 answers. The first one is just in that first quadrant, so hopefully should be pretty easy, just pi over 6. In the second quadrant, it's not going to quite make it to 6 pi over 6. So I would have to do 6 pi over 6 minus pi over 6 to give me 5 pi over 6. So there's another answer. When I take and look for the angle in the third quadrant, it goes past. So this time I'm going to have to do 6 pi over 6 plus pi over 6. And you don't have to show this work. You can do this in your head. So that gives you 7 pi over 6. And then the last angle is going to almost make it around a full circle, but not quite. So it's not going to quite make it to 12 pi over 6. So I've got 12 pi over 6 minus pi over 6. And that last angle is 11 pi over 6. All right, this is a lot to take in. We've got a few more to do. I'm going to do this on a different video so it's not so long here. All right. Make sure you guys do watch the next one though, because there are some good ones on there.